Hello, everyone. Good afternoon. A lot of AA stuff probably you would have seen. So I should be the one managing the slides. So I'll take it. Thanks. A lot of AA sessions that you would have heard from the morning, a lot of AA content. Being lunchtime and also given my penchant for movies, I thought I'll start off with something that offers an interesting combo before we get into the AA piece. Before I talk about AI or anything, just wanted to briefly introduce. Zuci Systems is who we are. I'm the founder CEO, like she introduced. We are a new kid on the block. We are just 9 years old, doing some interesting work in AI. Small, but trying to put a dent in the AI space, and that's what we'll look at when we talk today. That being said, I'll probably jump right into the topic of my speech today, keynote speech today. I chose to talk about not just AI building models, prompts, and things like that, but we have a very interesting case study that we have done. So I thought I might be able to share some knowledge and some valuable insights based on the work that we have done, which is very unique, and for a marquee client, I believe not many people would have gotten into this level of work in AI, even in larger companies, not talking about it in terms of, or not presenting or trying to put it in terms of a brash, arrogant mode, but more in terms of the pride from where this work has given us. Many of you would have seen this movie called The Founder. It's based on the founder, not exactly the founder, actually McDonald's founder was not Ray Kroc. He took it from the McDonald brothers actually, but he's credited mostly as the founder of McDonald's because he was able to visualize the McDonald's franchisee approach, the vision and everything actually. So if you have seen this movie, one of the interesting lines in the movie that he says is, the true innovation for McDonald's was not the burger itself, it was actually the system behind it. Right? Because today, if you look at it, you go to Kochi, you go to Chennai, you go to Alaska, you go to California, doesn't matter. The fries is all the same. The burger is all the same, right? And that's what we talk about. How do they manage to create a backbone like that for a brand like McDonald's, right? So this line has always stayed with me. And I think this line today captures the entire truth of enterprise AI. What we need to do in enterprise AI today is building this big backbone for AI success. Because building a model is probably the easier thing because there is code available, there is low code available, you have so many platforms available, futuretools.io available, everything is available. Building code with AI, building an AI model is today probably the easiest thing to do. But the real question is, how would you really scale this model? How will you make sure you are able to orchestrate this model, scale this, and create the impact that is needed? In the B2C world, ChatGPT is a classic example. We don't know how it even works because every single person is using ChatGPT across the world. So you can imagine when I talk about orchestration and scale, I'm coming from a standpoint where, when an AI model is deployed and it is supposed to cater millions of users and things like that, how do you really scale or how do you really put together a design, an infrastructure, a data, all of that coming together and making it work? So that's precisely what I wanted to talk about based on some of our experience. And that for me is the hidden backbone of AI, and that's where I wanted to talk about orchestration, scale, and impact. That being said, like I said, today when we talk about AI, we talk a lot in terms of Copilot demos using tools like Cursor, Replit, Claude Code, and things like that, which is all good actually. But they are all still in scratching the surface kind of a mode with most organizations, in terms of how do I bring in Copilot, how do I measure the productivity, what is Copilot really doing to me, am I going to replace developers with AI and things like that. All of that is, good to have, nice to explore kind of a space basically. But the real challenge when it comes to deploying AI in enterprise systems based on what we have seen is, it needs to work in that ecosystem really well. It needs to take into consideration all of the challenges that the ecosystem offers, could be in terms of scale, in terms of the infrastructure that is needed and things like that. And that is where the real challenge comes in. So the genius of building a model is one thing, but the true genius is actually making that model work in a real-world enterprise system. That's where the real challenge or the real genius lies. So, like I said, inside enterprises, the real challenge is very different. It's not whether AI can work, but whether it can work reliably at scale and inside real systems. And that's what we are going to talk about based on an experience that we have done. So the story that I'm about to share is for a Fortune 20 client that we have been working for the last 9-10 months now. They were with AWS Tesseract last year. The challenge for them, or the problem statement was, they are processing 60 million, or they were processing 60 million cases in a year. In the US, as you know, a lot of surgeries, procedures, and everything involves prior authorization, in the sense you can't get everything from your insurance. So sometimes your insurance company might say, you need to go and get a prior authorization for this. So in such cases is where the 60 million cases comes in. So the patient will have to go and present his case, look for prior authorization, insurance needs to approve it, and then it goes back and forth, goes back to insurance, they need to consume it and things like that. So 60 million cases of prior authorization in a given year. And they were using, they needed document intelligence basically. Until last year, they were on AWS Tesseract, about 4 to 6 cents per page. And when I say 60 million cases, one case can have up to 25 pages, anywhere between 5 to 25 pages. And each page will have a set of information, patient name, patient address, these, that, everything, the kind of the disease, more intricate information about the disease and things like that. So the challenge is you have to extract everything from, not everything, you have to extract some set of information from every page. You have to make sure that there will be some level of handwritten content, there will be some scanned or typed content or whatever, or it could be mixed basically. And you have to make sure that the extracted content matches what is in the field and things like that. But why AI here? The biggest challenge is not every report that comes in for consumption would be the same. For example, in one case, in a particular page, you will find name at the top of the page. In another page, it could be on the right side. Another page, it could be on the left side, something like that. So you need to build in some kind of intelligence with AI, and the model needs to be very agnostic. So they wanted more precision, they wanted more control and more speed and things like that. So they came to us based on some demonstration that we did in terms of our AI capabilities. So this year, they came to us. And like I said, we had to put together some kind of an agnostic model that includes things like random forest, gradient boosting, and things like that. But at any given point of time, it will not stick to one particular model. When the page comes for consumption, it has to choose what model to deploy, what GPU to go after, a lot of things actually. We'll talk about it in a little bit. But that's the challenge. So with AWS Tesseract, they were spending about 4 to 6 cents per page, and that's the kind of challenge that I'm talking about. 60 million cases with about roughly 10 to 25 pages in each case, and that's what we tried to solve with the model that we built for them, especially around the infrastructure piece. So the biggest challenge was you cannot predict the production environment for AI. I mean, for that matter, in any enterprise, it's not easy. Especially in an AI deployment, it's not going to be easy at all. So the production itself was like 6x times bigger than what we were offered to do the testing, basically. So which also means that we had to simulate the unknown, which is predict the behavior, estimate the load, and design for an unseen scale and things like that. So naturally, we combined some level of first principles reasoning, including data pattern analysis, and of course, did some level of reasoning, gut instinct, everything put together. But like I said, the key was we were asked to build an AI system to actually replace AWS Tesseract that would read every single page, extract the key fields, verify the accuracy, complete each case. And the SLA was that if it's a case with lesser number of pages, you can do it in 20 minutes. If it has got the max of 25 pages, we have to do it within 60 minutes. While the SLA might sound like, wow, 60 minutes is too much, you can understand the level of information that goes into each page. It was not easy, actually. So if you remember the first slide where I spoke about the burger, imagine taking this analogy and applying it to the burger scenario. So if you want to make one perfect burger at home, then it's very easier, right? You basically know what ingredients, what to put in and get it ready and things like that. But imagine if you have to do the McDonald's thing, which is if you want to plan the kitchen, you want to look at how many burgers would be consumed in a given day, given week, given month, and then how do you feed your customers faster, cheaper, but better. So that's the orchestration scale and the impact problem that we came across. So the orchestration challenge was like this. One is we actually built an orchestration pipeline where every incoming case that comes in for consumption triggered a cascade of intelligent micro decisions, basically, which also meant, or as part of the decision, we had to make sure which model to invoke, which field to prioritize, when to escalate for human validation. So there was also a human in the loop kind of a scenario where you cannot do everything in an automated fashion in AI. So when we see an outlier scenario or when we see that something looks like an anomaly, it had to be escalated to a human in the loop, basically, which is the client's quality team and things like that, which they will actually do double accuracy and things like that. Again, environment was the most biggest challenge here because we are talking about almost modern AI workloads for LLMs, Gen AI. So we had to actually bring in IBM for the hardware piece because GCP and Azure and AWS are pretty expensive. So we chose to go with IBM. And we used Intel Gaudi for our infrastructure. And of course, Microsoft Azure had VMs that are offered with Tensor Core GPUs from NVIDIA. So we actually used H100 from Tensor Core, NVIDIA basically, and we took Azure VMs that had that kind of GPU processing power to do this. So every decision focused on precision under pressure, and like I said, the infrastructure or the production infrastructure was not known to us, so we had to plan everything based on that 6x size of the production and everything, and selecting the right middleware, right GPU model, and at the right time, while meeting the SLA of about 20 to 60 minutes, basically. So next came the scale challenge. Like I said, the infrastructure or the test environment was not really close to production. It's like doing a symphony preparation or a rehearsal in a small room, while actually you will be doing it in the Royal Albert Hall in London or something like that. So scaling here was not just about adding servers. You have to do a lot of thinking around the kind of infrastructure needed for production. And again, it was about thinking like production while working with a fraction of the capacity, like I said earlier. And we had to build synthetic workloads, simulated peak traffic, stress test memory thresholds, all with just that 1/6 of test capacity or test environment that we had. So we had to rely on patterns, instincts, or orchestration discipline and things like that to make sure that when it goes live, it doesn't actually fail. It was a very, very critical assignment for us. We were under a lot of pressure, so we had to take a lot of things into consideration before we went live. Like I said, it's a Fortune 20 client. And this is the impact that we eventually had after all the orchestration scaling and everything. So, almost a 2-minute turnaround per authorization request, which means that not the page time, but in terms of the turnaround, it was 2 minutes. And then the human in the loop actually was reduced because of the automation AI effort that we brought in. The processing errors were reduced. And then 23 million pages processed monthly without extra headcount. And I'm talking about only 2 months of production. 60 million pages in 1 year to 23 million pages almost in a month. In the last 2 months, we have seen this. And obviously, the maintenance cost has come down significantly based on a math that we did compared to AWS Tesseract. And then they have seen a fair level of revenue growth as a result of the consumption of the fax reports and things like that. So what we continue to see is today deploying AI, or one of the learnings that I wanted to share from this was, today AI is not about thinking about a model, but AI needs to be thought like infrastructure, which means that it has to be scaled, it has to be governed, it has to be measured, and it has to be well managed. So thinking about AI means that you don't think about just a prompting or a model or anything, you have to think about the infrastructure behind it. That's the biggest learning that we had in this process. This was a near transformational superhuman effort, like I said earlier, because that's why I started by saying that I'm not sure how many organizations would have managed this kind of a scale, even larger organizations. So this was almost a very difficult effort for us for the last 8 to 9 months. But how was this possible? Like I said, infrastructure was the key here. unlike CPUs, one of the things our architects told was the H100 that we got from Azure VMs, the NVIDIA H100s, unlike the CPU era, the GPU era doesn't work like that. For example, you can't keep adding central processing units, or you cannot decide, I will get something tomorrow, like the case of CPU. The GPUs, if you're asking for, let's say, 10 from Azure or AWS or anybody for that matter, you can probably check this out, or probably some of you already know this. If you are asking for a set of N100s or any kind of latest, power-packed LLM-based or AI workload type GPUs, you cannot, rent them on a daily basis, or you cannot say that I will get it tomorrow, that kind of thing, even if you pay the money. If you tell that, I'm going to get it today, you have to get it today. If you tell them I don't need it, then it goes out. You cannot get it, at the pace in which you want it, basically. So one of the biggest challenges that we saw was, in terms of hype to value, infrastructure was the key element in terms of what we did. So GPUs don't scale the way CPUs do. So you just can't rent more and hope for the best. That was the biggest learning that we had in this exercise. So you need to plan the infrastructure, all of that accordingly, and make sure that the kind of GPUs you need, the power that you need in the GPUs and all that has to be well thought of, rather than trying to, come to a point and then figure out that, oh my God, I missed to ask for this. And it's not going to be easy to obtain them at that stage. So what that also means is the infrastructure that is needed for enterprise AI systems is not about throwing compute at the problem, which means you don't bring in server after server, add them to it and say, I've got n number of servers and hence the problem is going to be resolved. That's not the way it works actually. You have to think in terms of systems ahead of time that can simulate, adapt, and learn, because these are AI models. They have to learn, they have to look at the reports, they have to keep on being trained on the reports they are getting and things like that. So that simulation, adaptability, and learning was a very, very important thing in terms of going from this hype to value exercise for us. Again, the human in the loop element was very important, because when you deal with this kind of an infrastructure, this kind of an enterprise, you cannot think AI is going to do everything. So there is a portion in which you try to see if there is a human needed in the entire chain, and where they have to come in and things like that. For example, if you look at it, our client's quality team, they were into a lot of inspection of this, field extraction values and things like that. So with this, we were able to bring it to a significantly reduced level. But the most important thing was we were able to move them more towards insights rather than inspection. So the quality team, which typically when we talk about quality, we talk about them inspecting the output and things like that. We were able to move them from inspection to insights, I would say, despite having a fair level of inspection being done by the AI system. So that was another learning that we had in this process. Again, as I come to the end of this session, I'm going back to the burger piece actually. So when I think about this project, I always go back to that founder statement, or the founder movie statement that I opened this session with, which is, the thing, it was not about the burger itself, it was about the system, right? So because what we built was not a better burger, it was a better kitchen actually. So orchestration made it reliable, scale made it powerful, and the impact eventually made it meaningful in terms of all the planning and everything actually. So the same principles that built McDonald's into a global system are what enterprises need for AI today, which is repeatability, reliability, and rhythm. Closing remark, outside of the burger example, a lot of us would have taken a flight this morning, and I also took one from Chennai to Kochi. It looked all very calm in the skies, actually, but I was also thinking, at least, probably 5,000, 7,000 flights are right now mid-air, in any part of India going from one place to another. How well they are orchestrated, basically. Somebody is sitting in the air traffic control here. When I say somebody, a team is sitting out there managing these flights and everything, right? So you can imagine in the aviation sector, the kind of orchestration, scalability, and things like that is a very classic example in terms of, how smoothly the flight runs for a moment if we take flight to be the AI model, right? So I just wanted to end by saying that the brilliance of the model is very visible, but the orchestration is what actually keeps it reliable. That's the real power when it comes to AI. And like I said, as we build the future of enterprise AI, we got to remember one thing, which is code creates intelligence, but infrastructure is what creates the impact. I just wanted to share this knowledge with all of you. Thank you so much for patiently listening to me.
So if you have any doubts or questions, you can ask now.
There's a question, Q&A? There's a Q&A? Oh, okay. Yeah. I can hear you, yeah.
So this sounds very fascinating, and I want to understand how do you load test this infrastructure before rolling it out, and how do you define the SLAs?
We were able to get the pattern from 2024 from them actually. That was one good thing that happened in this whole process in terms of an objective number, I would say. A lot of other aspects were very subjective in nature, very relative in nature. But I would say that the pattern that we saw from the pattern that we saw from 2024 gave us some level of confidence in terms of the thresholds that we need to carry when it came to stress testing. How do we make sure we would have done at least 100 runs, by the way, in test, not something like we did once or twice. Before it went live, we would have done at least hundreds of runs actually. That's why I said the production was 6x bigger, and we had 1/6 of that environment in testing. So you would have imagined how much we had to think about stress testing, the thresholds that we need to carry and everything, especially given an SLA. So the SLA, by the way, has not kicked off yet, but that was signed as part of the statement of work or the contract basically. But for the past 2 months, it has been in production. We are almost processing, I said 23 million cases per month actually. So far, we have had some hiccups, but nothing major has come up in order to kick off or trigger the SLA basically. I hope that answers.